Morandini. Yes, I did. Kylie. Kylie's not in this class. Everybody got paper? Yep. Everybody got paper. So if you can fix that, and then I'll get the other guy in. Well, we need to figure that out. They're going over their homework, so they've got something to do, and I'll be right back. Yeah.
Oh gosh. I missed like this one because I couldn't remember like what I was supposed to do. I was like, I'll just write some to pretend like I can't do it. Like that. It didn't work.
What was funny is I started doing the equation and I was like, no, that's not right.
Oh, that's nice. I was smaller than this one. And I got like, because I used different books. Yeah, so I like, I changed.
I know what you got.
I didn't, I didn't know. I didn't watch you too. No, I don't know what you got. And like right before the test, I was like, okay, I'm done the best. Have us years over here all the time. Then I didn't change it to liters. That's so silly.
Like I didn't see the leader.
Because like, I mean like you did the
Yeah, makes me so
And
mad.
like based on the homework, like you know that it's
Yeah, we were talking and I was like, oh, by the way, I just want to tell you, you're getting your test.
I literally went to like a bajillion times at like 5 because I was like,
Me too.
read your first test. I know, I like
I was getting so far.
I was over the
I switched
right
those
before the
over.
test, I was like, okay, I gotta make sure I change it to liters. And I was like, change it to liters.
See, if I would have like decided it doesn't come
And
down
like
to
that top
part
one,
one,
I was like, I have no idea. So I just like changed it, like, I
I'm so
changed
mad
it
at
around,
myself.
like wrote what everything was. And I was like, I was like, I'm not gonna start anything because I'm not even sure it's a circle, so we'll just go with it. And I was looking at it, and I was like, is that cool? And I was like, okay, so it's like 750, but then it says CC Jordan. Right. How do you do whatever? You were actually supposed to do an equation. Imagine that. Doing an equation? What? I've never done that before.
I know, right? I feel like, well, now I understand it all. I was like,
Right.
oh, you're so stupid, Marty. In the
I
present.
know, I feel like they have this
I did
test.
this leader part, so then I got that problem, like, how to come now. So mad.
I had no idea what to do guys, like, so I just like wrote some stuff. And I was like, I'll just pretend that I really enjoy it. And I was like, I got the test copy, you wrote on there, I'm not sure where your friends wrote this. And I was like, I was like, well, I'm not sure either. I just wrote the one.
I'm just going to that. So if I we sat in, they were like, well, thank you very much. I was like,
Okay, let's get started here tonight. I apologize for the delay, there's been a few things running around here at the school that needed to be tidied up, so we are all good. Someone brought up the movie, like I said, I think we're probably in good shape for the movie, but I don't know for sure, because I don't even know the number. I didn't notice it whenever I was putting in your grades. If we do get a movie, we'll be able to find out by Monday and we'll watch some Karate Kid. But in the meantime, so that we're not wasting the day away here, let's jump forward then into the next section, which I think a lot of this will be familiar to you, is chapter 12. Which, having just talked about gases, we're going to talk about solids and liquids. And in particular, as we get into liquids, we're going to talk about water, since it's so chemically important. Shoot, right? 70% of the earth is covered in it, and 70% of your body is made of it. So it's pretty important stuff. So water tends to be discussed quite a bit. Now, I think we have a basic idea of this solid liquid gas thing. If I wanted to draw pictures of solids, liquids, and gases, particle model wise. Remember, the solid is very regular. The particles are,
Is this a three-part question?
no, that should be a one
oneer.
answer, a oneer,
A water.
a oneer.
The water.
Liquids are still compact but less organized. As a result, they take the shape of their
Bless you.
container. And the gases are distinct particles. Now, let's take something that we picked up from last time and apply it to these ideas. Think in terms of pressure. Right now, is there pressure on you? Yes. Why? Why is there pressure on you just sitting around as you sit here right now on Earth at its surface? Why is there pressure? First off, what is pressure? Well, what is pressure in general? Pressure is bombarding particles. So yeah, okay, so why are we under pressure right now? Particles in the air, they're bombarding against us. Remember, currently, right, there's 14.7 pounds per square inch of pressure. That's 760 millimeters of mercury worth of pressure. We're about at sea level. That's a lot of pressure if you think about it. And that pressure is going to force particles together. So solids and liquids are held together by the pressure of their surroundings, and the gas particles, in a way, are free of that pressure. The gas particles have found freedom, because they're no longer interacting with each other on like a personal, direct connection level. They're interacting with each other on fly-by, bounce-by level. Make sense? So think in a way of gas. One way to think of a gas is freedom from freedom from attraction of neighboring particles. The solids and the liquids have some attraction between neighboring particles that's keeping them in their compact form. The gases have freedom from that attraction. Now, if I had a solid, what could I do to turn it into a liquid? Okay, so what would you have to do to melt it? Use heat. Great, perfect. So if I go from a solid to a liquid, if I increase the heat, when you increase the heat enough, you increase the motion of the particles enough to where rather than the particles being in a perfect orderly fashion just jiggling next to each other, they start to move enough to where they can slide around each other. And that's what gives you this liquidy consistency. Heat the particles up enough, they're going to get moving enough to where they can break free. That's basically the boiling process. Let's talk about that. Well, let's actually, Holly, what word did you use when you said go from solid to a liquid? You would melt. Let's make sure we have all these words right, because these are good words to know when we're in a section about solids and liquids. We gotta have it straight. So, when you go from a solid to a liquid, it's called melting. When you go from a liquid to a solid, freezing, right? Now, every substance has a melting point. Every substance has a freezing point. They're the exact same temperature, and it's a particular temperature when we go from a solid state to a liquid state. So, just to be clear here, melting point and freezing point are always equal. It's not like you turn a solid into a liquid at a particular temperature, and then a liquid to a solid at a different temperature. For water, just so we know this, does anybody know what the freezing point of water is? 32 degrees Fahrenheit or 0 degrees C. So for water, it's 0 degrees Celsius. If you want your ice to melt, heat it up to 0 degrees Celsius. If you want your liquid to freeze, cool it down to 0 degrees Celsius. Melting point, freezing point are the exact same temperature, but they're going in different directions. Okay, what about when a liquid turns into a gas? What's that called? Okay, what did you just say?
Just like vaporization.
Vaporization. Now there's actually two words to describe this, and we're going to differentiate between these. One is evaporization. Evaporization. And does anybody have another word to describe when a liquid turns into a gas? Think about when you put water on the stove and you maybe making a boil, okay? So evaporization and boil. Now, every liquid has a boiling point. Every liquid has a point to where a temperature, to where you heat it up enough, and those particles are going to move enough to where they can break free. That's called the boiling point. Evaporization is when a liquid turns into a gas at temperatures below the boiling point. Because let me ask you, science experts here, what's the boiling point of water? Does anybody know? The boiling point of water? If the freezing point is 0 degrees C, the boiling point is 100 degrees C, which is 212 degrees Fahrenheit. Now, let me ask you this question. Have you ever seen water turn from a liquid to a gas at temperatures below 212 degrees? Have you ever seen water turn from a liquid to a gas at temperatures below 212 degrees? Yes?
Like when rainwater evaporates?
Okay. Have you ever seen it rain? Have you ever seen a puddle? Have you ever seen that puddle disappear? Have you ever seen that puddle disappear at temperatures below 212 degrees? Okay, that's evaporization. Right, as I ask the question, you guys are thinking, oh man, liquid, have I ever seen water turn into a gas? Yeah, you have all the time. All the time it happens. That's called evaporization. The way you can think of evaporization is basically when the liquid particles are moving around as they are, by chance, when the particles would run into each other, they might run into each other just right, and one of them might scoot free. Actually, this is perhaps interesting to you, but this last semester, on 10/24, whoops, I had this water bottle filled with water to the level of this line on 10/24. There's no longer water in the bottle. It evaporated. Was it ever 212 degrees in this room? No, it probably never got above 75 or 80 tops. Yet the water turned into a gas. That's what evaporization is. And it's one particle at a time. When evaporation is occurring, you're not going to see it. When boiling is occurring, you are. You're going to see the bubbles. Okay. What about the other way? What do we call when a gas turns into a liquid? Does anybody know that word? So we have gas, like water vapor in the air, and then it turns into little beads of dew on your car windshield. Condensation, nice, okay, good. Now, to make the point again, just like the melting point and the freezing point are the same temperature, the boiling point and the condensation point are also exactly the same. So whatever temperature the water will boil at is exactly the same temperature that the water will reliquefy at. And that's for water, 100 degrees C. But it's true for any substance. Salt. Salt has a melting point of 801 degrees C. So imagine you had salt, and you heated it up to 801 degrees Celsius. That's about 1700 degrees Fahrenheit. You turn it into a liquid. You could have liquid salt, right? If you heat up the salt to 1400 degrees C, it turns into a gas. That's about 2800 degrees Fahrenheit. You could turn salt into a gas. You could have gaseous salt, right? It seems unbelievable, but think of it on a particle level. Be particular, right? Funny? No? That's a Friday joke response, apparently. Yeah, on a particle level, the more you heat it, the more you move the particles. It doesn't matter how solid something is. You heat it up enough, it's going to liquefy. Another example, what do we got here? Ooh, diamond. You heat a diamond up to 3700 degrees C, it liquefies. Okay, so 3700 degrees C, double it. It's about 7400 degrees Fahrenheit. That's pretty hot. That's like mantle hot. But if you want a liquid diamond, just get a lot of energy, pump it into the diamond, and those particles are going to heat up enough to liquefy. Go up to 4200 degrees, and you're going to get gaseous diamond. You could turn a diamond into a gas. Isn't that kind of cool? I think it's kind of cool. The book also has a couple others. Copper. Ooh, iron, even better, iron. Like the steel in your car is primarily iron. 1535 degrees, it'll turn into a liquid. My dad works up at Steel Dynamics. They deal with liquid iron all the time. They take scrap steel, like steel that everybody just wants to throw away, like junk cars, for example. Or, I don't know, what else would be made of steel? Like maybe a set of shelves, like garage shelves that somebody throws away. Chairs. People throw away metal. And what do they do with Steel Dynamics? They put it in a big pot, and they heat it up, and they melt it back down. That big pot takes a lot of energy to heat up the steel, because you have to heat up the steel to 1500 degrees C to melt it. That's 3000 degrees F. When these little, they do it electrically. They have these electrodes, one positive and one negative, that submerge themselves into the metal, and they start charging the metal electrically, and they heat it up using electricity. One, it's loud. Two, it's really, really hot and incredibly dangerous. Imagine 3000 degrees Fahrenheit iron, like in a molten pot. You don't want to be standing anywhere near this thing, and in fact you don't. When you melt the steel and you drop the electrodes in, everybody goes behind a door with a piece of glass. And actually, the place has been around for 10 years. They now have 2 pieces of glass. Because the first piece of glass has had enough molten steel be shot at it, because imagine you have this bubble, this pot of liquid metal. You're going to have little hot spots where it boils off. And you're going to have molten balls of steel flying hundreds of feet. There was enough molten balls of steel that were going at the 5-inch thick piece of plexiglass or whatever it was, that it started in some spots that were hit particularly often, it started burning through. And there would be people behind this glass, and then there's a piece of steel coming at them, and it comes through the glass. That's when you put up a second piece of glass, right? This is dangerous stuff, but this is hot stuff, just something to think about. Your car, if you wanted to, you could melt. Actually, funny story, speaking of Steel Dynamics, The vice president of Steel Dynamics, he's worth like $150 million. That's his net worth. That's pretty good, right? Like that's like Jay-Z money. That's good. And he's in Fort Wayne. His name's Dick Teets. But anyways, he drove around until about 5 years ago. He drove around the Ford Escort that he first purchased when he got his first job. And this car was old, and it had a ton of miles, and it was probably worth $400 in the condition that it was in. Rusted out, whatever. $150 million man driving the car and driving to work in this little Ford Escort. Well, guess what people did as a practical joke to him? They stole his car. They stole his car, and they took it to the melt shop. And they took the magnet, and they picked up his car, and in front of him, they dropped the car into the liquid metal. And they bought him a Mercedes, or something like that. But it was devastating to him, because this is a part of like who he was. Like this is what he wanted to show as a manager. Like, I'm a $150 million man, but I'm not a changed man. I still drive my Ford Escort. It was a kind of a mean joke, but anyways, the point of the matter is, if you heat up a car enough, you can turn it into a metal. You heat it up to 2,750 degrees, you'll make gas. You can vaporize a car. You can think about that. And Kramer and I the other day were talking about atomic bombs. Yeah, that gets hot, really, really hot. You can actually think about that on a pressure scale. Imagine your bomb here. Here's your bomb. It kind of looks like a fish. Here's your bomb, right? And inside, you got these nuclear reactions occurring that are increasing the temperature. And as you increase the temperature, you're increasing the movement of the particles, which is also increasing the pressure. And guess what? You increase the pressure enough, the gum bubble pops. The plastic bag pops. The bomb, made of whatever it's made, explodes. And guess what? Atomic bombs are hot enough, they can vaporize cars. They can vaporize you. They can vaporize houses. So, something to think about. Anything heated up enough, you can take it to the point where it's a gas. Kind of neat.
There's 2 questions on here, just read them real quick.
Okay.
One's for Ally, because I want her to have the 10th grade, and then I'll update.
Unfortunately, since our PayPal transactions are unusual because we don't have them enough, they're having to send something to our house to verify before they can even transfer the money.
Don't.
Did you sign this?
Of course.
No way, Jose. Just kidding.
Nicely done, by the way.
Thank you.
Studying my butt off.
It showed.
Hello. Hello. I had any questions yesterday. Any questions? No, I don't think I did. Oh, yes, we did.
Yes. Sure, yeah, that'd be great. Appreciate it.
Maddie, did you get number 14? Yeah, 14 was still. What was last week? It was, lesson 61. 11 to 15. I think it was 9. Did you have, who's teaching the technique class today?
Don't.
What? You have to be in the teaching technique class today?
I'm guessing Kevin. Well, actually, no, that's not good, because I have Kevin, because I have 10 men's spots, and I have partner. So I have Kevin. You have, I mean, the
Thanks, Aaron.
No problem.
I don't have partnering today, I have variations.
so how, oh yeah, well, at least in the
Do you think that you'll be going to the laser tag today? Or
Uh,
later tonight?
I don't know.
And Paige, you said that you were going.
My grandma's gonna be
grandma,
expecting.
yeah.
Your grandma's thing?
No, my grandma's going to my house, so
I think it's like,
Seeing a grandma on laser tag?
Oh, that would be awesome.
That would be awesome.
Fun laser tag story, fun laser tag
Oh, by the
story.
way, are you going Mr. Black today?
I am not, but I do have one fun laser tag story. When I was in high school, when you play laser tag, cause you know they like keep score, right, each round, whenever you play? And you know how, you're probably, whenever you go there, and I don't know how it works now, but you might just be listed as like player 12 or something, right? Like, but some people have like their own names, like, you know, like Bad Dude 21 or something. And these are like the people who have like a membership, they show up all the time. They may be 30 years old and live in their parents' basement, like those kind of people, right? Well, my best friend and I went to laser tag one night in high school, and my buddy John, who, like I said, my best friend in high school, he gets one of these. He finds one of these guys, and he says, "Hey, I'm gonna be like your dummy. Like I'm gonna be your cover man. Like I'm gonna go out in front, and then you're gonna follow behind. I'm gonna take all the damage, and because you know you can get stunned to where your lights turn off for 20 seconds. He's like, I'll just stand in front of you so that nobody can shoot you. And John was a college basketball player, 6'4", big wide frame. So the guy's like, oh man, you know, really excited. So John and this guy are traveling, and John's taking all the bullets, and they get up to like the main thing that you shoot at that gives you like all the points. So of course this guy who's a regular is so excited because he's gonna get like the highest score he's ever had in his life. And John turns around right at that moment and starts shooting him.
Oh.
And the guys are
Wait, don't they have
a
a friendly fire?
There were friendly. You could shoot. There were no friendly fire restrictions. So he just starts shooting him and then disables him, and then 15 seconds later disables him again and just starts following him around. he ended up relenting at some point, but that's my funny laser tag story. I think that's
I'm about to get the name Tiger Shark 55.